So hello guys and welcome to my channel sir. Today again I am back with another important numericals or numerical methods sir. And today in these lectures we will discuss the numericals related to Laplace equation. And here we have the question as the steady state two-dimensional heat flow in a metal piece of size. Here we have given the metal piece of size 30 cm into 30 cm is defined by the equation del square t upon del x square plus del square t upon del y square equal to 0, and two adjacent sides are placed at 100 degrees Celsius and other side is at 0 degrees Celsius. And here we have to find the temperature at inner points assuming the grid size of 10 centimeter into 10 centimeters. And here we have given the metal plate size of 30 cm into 30 cm means this is of means this side and this side is of 30 cm. And here we have the grid size is given as here 30 means 10 cm into 10 cm means is grid size. Here this is 10 and again this is of 10 cm into 10 cm sir. And here we have given the Laplace equation as del square t upon del x square plus del square t upon del y square equal to 0. And here two adjacent sides are placed at 100 degrees Celsius, and two adjacent side means this side and this side are placed at 100 degrees Celsius and the other side at 0 degrees Celsius. And here other side include this side and this side. And here we have to find the temperature at inner points assuming the grid size of 10 cm into 10 cm. Means here we will have altogether the 9 grid means it will be the size of row into here it will be the box of 3 into 3 means 3 row and 3 column will be made here sir. And here we can see here to calculate the value at point f1. At first we have to calculate the value at f1. So to calculate the value of f1 we will follow the pattern as here this plus pattern. So for f1 it will be this 100 plus this 100 plus this f3 and plus f2 and divide by 4 means 100 plus 100 plus f3 plus f2 upon 4 means we are following the pattern this plus sign to calculate the value at f1. Similarly to calculate the value at f2 again we will use the same patterns means f2 and here we have f2, so we'll use again the plus pattern here. So to calculate f2 here we have 100 and this side is 0 and this side f4 and this side is f1. So here we have 100 plus 0 plus f1 and plus f4 and divide upon 4 means upon 4. So f2 will be 100 plus 0 plus f1 plus f4 upon 4. And similarly here we can see at f3. So at f3 again we'll use the same pattern means plus pattern. So here you can see at f3 again we'll use this plus pattern here. At f3 you can see this side is 100, so 100 plus this again 0 plus this side f4 and this side f1. So at f3 we have 100 plus 0 plus f4 plus f1 upon 4. So this is equation 3. Now at inner point f4 again we will use the same pattern means plus pattern. And here you can see at f4 here we have this 0 again this 0. For this here we have 0 again we have here 0 degrees Celsius and here we have f3 and here we have f2. So here we have at point f4 we have 0 plus f3 plus f2 upon 4 and this is equation 4. And here we can notice one thing here, the value of f2 is 100 plus 0 plus f1 plus f4 upon 4. Similarly the value of f3 is 100 plus 0 plus f4 plus f1 upon 4. And we can see here the value of f2 and the value of f3 are same, so we can equate these two equations. So here I have written since f2 is equals to f3, so if you solve we will get the value of f1. So once we will get f1 as here 100 f2 upon 2, and now and here we have f2. From equation 2 we can use the value of f2 as 100 plus f1 plus f4 upon 4, since here we have the equation 2 as 100 plus 0 plus f1 plus f4 upon 4. So from this, if you use the value of f2 here we have f2 is equals to 100 plus f1 plus f3 upon 4. And similarly from 4 we can calculate f4. So here we have f4 is equals to f2 upon 2. So here we have used this f4 from this equation 4. So here we have f4 equals to f2 upon 2. And now we have to choose the initial gas. So again here we have the trick to know the initial gas. So if you are calculating the initial gas at point f1, you can use this multiplication sign, means multiplication pattern, this cross pattern. So if you use this cross pattern for f1, so you get here from the means this whole side is 100 degrees Celsius, again this whole side is 100 degrees Celsius, and this side is 0, similarly this side is 0. So to calculate the initial gas at f1, here we use the cross patterns. So for this we have 100 plus 100, again here we have plus 100, and here we have f4. So in place of f4 we will use 0, means 100 plus 100 and again 100, means we have here we are using the cross pattern. So first here we have 100, this 100, and again this point 100, and for f4 we will have 0, means 100 plus 100 plus 100 plus 0 upon 4. So we will get here 75. So here we have used cross pattern to calculate the initial values at f1. Means we have here 100, again plus 100, again plus 100, and in place of f4 we have 0. So 0 upon 4. So if you solve this, you will get here 75. Similarly, to calculate the initial gas at f2, and here to calculate, here we have the initial gas. To calculate the trick to calculate the initial gas, first we'll use cross sign, and then for remaining we'll use the pattern plus, these plus patterns. And now right now we are here looking the initial gas for f2. So we'll use these cross patterns, not cross pattern, these plus patterns. So for this, here we have 100, this 0, again this is for f4 0, and for f1 just we have calculated. So for f1 we have just now calculated 75. So 75 plus 100 plus 0 and plus 0 upon 4 will get here 43.75. We'll get here 43.75. And similarly for f4, here right now we are calculating for f4. So if you see here the value of f4, since these two sides are 0, so you can simply use the value for initial gas as 0, or simply you can use the pattern plus, or if two sides are given the 0 degree Celsius, so you can simply use the value of f4 as 0. Now we can simply solve these equations. Here we have equation from here we have equation 1, similarly equation 2, and similarly 3. And here we need to calculate the value of f1, f2 and f4. Since once we calculate the value of f2, we'll be able to know the value of f3, since f2 is equals to f3. So here we can simply use the Gauss siedal method to calculate all the values. And if you don't know to solve this, you can check the description below. I have attached the link how to solve this with the help of calculators. So you can check the link in the description below. So this was all for today. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.